Right, we're going to have a look now at the transition metals, and these are all the metals that are sort of sitting in the middle of the periodic table, that are between the groups, so they don't actually fit into the groups, but they still have some properties that we need to look at. They've got the typical properties of metals, you know, that they are shiny when cut, they're strong, they're malleable, which means they can be bent or hammered into shape. Now there are some compounds that are often coloured, and you need to know some of these. Copper compounds such as copper sulphate solution are often blue. Iron 2 compounds such as iron 2 sulphate solution are often light green. And iron 3 compounds such as iron 3 chloride solution are often orange or brown. You need to learn these because these colours of the chemicals keeps coming up that you need to know them. If you remember back to group 1, we said that lithium was red, sodium was orange, potassium is purple or lilac. When we looked at group 7, we said that chlorine was a green gas, bromine is an orange liquid, iodine is a grey solid. So these are some more that you need to learn. Many of the transition metals are used as catalysts, and if you remember, a catalyst helps to increase the rate of a reaction. So for instance, iron is the catalyst for the Haber process, and if you remember, that's all to do with nitrogen and hydrogen being joined together to make ammonia. Nickel is a catalyst for the manufacture of margarine, so there's another example that you could use. Now at the end of the last video I started to mention this term thermal decomposition because it sounds quite complicated, but actually it's fairly straightforward if you look at the breakdown of the words. Thermal means heat, decomposition, decomposes, means breaking down. So all you're doing is using heat to break down your metal carbonate. Okay, so if you look at these symbol equations here, they look quite complicated, but really they're not, because they're all the same. You start off with the metal at the beginning, so you've got iron, copper, manganese, zinc at the beginning of the symbol equation. Then you've got the carbon, and then you've got the oxygen. So this is telling you it is a metal carbonate, and all you do is heat it up, and when you heat it up you produce two new products. Well, really the clue first of all is that you've got a carbon in there. Well, if you've got carbon in your original reactant, then you are going to make carbon dioxide. So that's the first thing to remember. And the second thing is, whatever's left over after the carbon dioxide has been taken out is going to be your your metal oxide. So for instance, the first one is iron oxide, then copper oxide, and so on. So the way I look at this is, if I was in an exam, I'd look at the symbol equation for the reactant. I would take out what I know. I'd take the carbon dioxide out, CO2, because you know carbon dioxide, CO2, and whatever's left has to be the other product, because whatever goes in has to come out. And here is something else called a precipitation reaction. So some of these metal compounds in a solution contain metal ions, and they form something called a precipitate. And precipitate is like solid particles that can be left behind after two solutions have mixed together. So if you looked at the first one, for instance, and you looked at copper and you joined it together with hydroxide, you would get copper hydroxide. Iron, mix it with the hydroxide, you'd get iron hydroxide. But can you see the difference between Fe2 plus and Fe3 plus? And that was what we were saying about the actual colours. The 2 plus is the green, the 3 plus is the orange. So please just be aware of that. I'm not sure. You could remember maybe two E's in green. Maybe that will help you remember. Okay. Thank you.